This is the problem we talked about yesterday, correct? Do you remember this? We solved by elimination. We decided to eliminate x, and we eliminated it twice. And the reason we eliminated it twice was so that we would have two equations with just y and z. And then we used that as a whole brand new system and eliminated y and solved for z. Once we solved for z, we were able to substitute this into y. Substitute z into here to find y, and then substitute z and y into one of the original equations to find x. Therefore, we got our answer. Was anything that we did hard? No. There was a lot of places where we could make errors, right? We had to be careful with our negative signs. We had to be careful copying the problem correctly. And there's lots of steps, right? It's not hard. It just takes a bit, all right? So how about if I show you a shorter, faster way? All right. Now, there's multiple ways actually to do this in the calculator. Multiple ways. I'm showing you the way that I think is the easiest. There is another way that they show you how to do it in the book. Just to be clear. All right. So the first thing that we're going to do is before we even talk about that, I need to make sure you understand the word matrix. First of all, it doesn't have anything to do with Keanu Reeves. Nothing. Okay. And whether you think that's a real thing or just a movie, I'm not judging that either. Okay. A matrix is a rectangular array of numbers. It's a way to sort numbers. It's a way to hold on to numbers. It's a way to keep numbers all in one place. Okay. What we want to do is we want to convert our system into a matrix. All right. So this is what it's going to look like when we convert it into a matrix. Okay. We have these bars around it that tells us it's a matrix. Now look at the first row of the matrix. Where in the world do you think that came from? Hold on. What's the right word for the word numbers you're choosing right here? What's a mathematical term for a number in front of a variable? Starts with a C, O, E, coefficient, right? So what we did is we wrote down the coefficient. Now this one will get you if you're not careful. Do you notice it's a -3? Then we have to put a -3 here. Okay, so be careful of your signs. So what do you think the next row is going to look like? 3, 2, -5, -30. Everybody okay with that? All right, what about the last row? 2, -5, 2, -6. Any questions so far? Anyone? Okay, so this is the problem, right? This is what it says in the book. This is the problem. We're going to call this our problem matrix. Everybody okay with that? This is the problem. This is our problem matrix. Then we grab our calculator. Okay? Now, Bryn's going to write down the steps for me. We're going to be dancing back here, I think, trying to reach over each other and everything, but that's okay. Okay? She's going to write the steps for us over here if you want to write the steps. Okay? So first of all, this is the most important step. Turn your calculator on. You don't have to turn your calculator on. That's okay. Okay, we want to start a document that's a calculator. And I have to have it sideways like this or you can't see it because of the glare. So we're good. Okay. After you turn your calculator on, we want to start a calculator page. Okay, it's making me press menu. I want a calculator page. Menu. What do you think we're going to choose? Matrix. Now, for the record, at this point, there's several different things you can choose. Is it okay if I show you the order that I think is the easiest? Okay? What I think is easiest is to choose this one right here, reduced row echelon form. Notice please that there's a row echelon form and we're not choosing that. We're choosing reduced row echelon form. You can just put RREF. When I choose reduced row echelon form, look what it says on the calculator now. It literally says RREF, reduced row echelon form. Okay? Then press menu again. What do you think we're going to choose this time? Still matrix. That's what we're dealing with, right? But this time we're going to create our matrix. You see it? Very first. And what are we creating? A matrix, right? We're creating a matrix. So choose matrix. So choose matrix, right matrix again. Now look at our problem matrix. How many rows does it have? 3 rows. So we need to delete the 2 and put a 3. And I'm going to hit tab. If you use the up and down arrows here, it messes stuff up. It's dumb. I'm going to hit tab and delete. How many columns does it have? 4. Okay. Now, sometimes people get messed up on that and they put the numbers in the wrong order. But here's the deal. If I press OK, does this look like it needs to look? Does this look like my problem matrix? It does, right? So I know I have it right. If it doesn't, just go back and fix it. Go back and create a matrix again and make the numbers the right numbers. Got it? Now, here's the thing. I have to put this down so I can enter my numbers in, so it's going to be weird because of the glare. See what I'm talking about? Okay? But what I'm doing, let me see if I can do it sideways for a minute. What I'm doing is I'm going to hit 1 and then I hit tab. And -3 and tab. And 6 and tab and 21. And see why I hit tab? Watch what happens when I hit tab this time. Where did it take me? To the next row. Okay? I'm not having an up and down arrow everything over here. 3 tab. 2 tab. -5, -30. 2, -5. 2 and -6. Now before I go on, again you're going to think I'm weird. We already know that I am, so it's not a big deal. I'm going to look back at what I just put in. 1, -3, 6, 21. 3, 2, -5, -30. 2, -5, 2, -6. Is what I entered what I meant to enter? Yes. Then I'm going to press enter. Watch. Watch. Look at my last column right here. Look at my answer to the problem right here. Oh my gosh. Write the answer matrix right here. I want to make sure you understand why this works. Okay, this is also a time to teach you or to explain to you why we chose reduced row echelon form instead of just row echelon form. Okay. Now, this right here is only the answer because that is a diagonal of 1s. It's only the answer because that's a diagonal of 1s. Because if we converted this back into equation form, wouldn't this say 1x plus 0y plus 0z equals -3? Isn't it telling you that x equals -3? And 0x plus 1y plus 0z equals 2, isn't it telling you that y equals 2? And 0x plus 0y plus 1z equals 5, isn't it telling you that z is 5? That's why we look for the diagonal of 1s there. Okay? Now here's the deal. If I put this in row echelon form gives me a triangle of zeros down here, and that's it. It doesn't worry about diagonal of ones, and it doesn't worry about numbers up here. We want a triangle of zeros here, and we want a triangle of zeros here. Does everybody see the triangle of zeros? Both of them? When the triangle of zeros here and triangle of zeros here, when I have a diagonal of ones here, that is my answer. And we write it as such. Beautiful. So will we ever do any problems where this is not a diagonal of ones? Yes. I need you to know what to do. Okay? It's going to be harder for some of you than others because you have to think about it. That was just a little joke. Okay? What's going to happen is maybe this might be a 1 and maybe this might be a 1, but this is going to be a 0. Can you see how that would be a problem? 0, 0, 0, 5. What if it said 0, 0, 0, 5? Converting that back into equation form, what does that mean? 0 equals 5. Does 0 equal 5? Will 0 ever equal 5? No, so what do we write for that? No solution. Okay? However, there's another option. 0, 0, 0, 0. Does 0 equal 0? Yes. And will 0 always equal 0? Yeah, and so our first reaction is to put all real numbers, right? That's our first reaction. But all real numbers implies literally anything can be a solution. But we know better than that, right? All the planes, what's happening is all the planes are all meeting at one particular line, right? How many points on that line are a solution? All of them. And how many points are on a line? Infinitely many, right? Okay, so we have to specify it's not any number, it's not all real numbers, it's all the points on that line, but we can say infinitely many solutions. I'm not going to worry about finding the equation of that line. I don't have to do that. I just have to know that if it's all zeros on this bottom row, 0 does equal 0, and so there are infinitely many solutions. Okay? So a couple things to give you a heads up about. All right? If you get a fraction right over here, you don't automatically have to freak out. You don't. Okay? Now, a lot of the answers in the homework tonight are not fractions. So hopefully that's not going to happen to you, because hopefully you've already checked to say or to see, first of all, did I write down my problem matrix correctly? And then if I wrote it down correctly, did I enter it in the calculator correctly? Right? Hopefully you do that as you go along. And then if you do get fractions, look at your diagonal. Is it a diagonal of ones, or is one of these a 0 and you know something's wrong? Does that make sense? Okay? So here's what I expect as far as work goes. You're writing on the problem. You're writing down the problem matrix. You're writing down the answer matrix, and you're writing the answer. Does that make sense? Now, why do we still write the answer as a point? Because it is, right? It is. It is a point. It's a point of intersection of 3 planes. And you're right. I didn't tell you not to yet, did I? Okay? Do you have any questions about this so far? If you do, please, as we have time to work on this, please ask. Okay?